All right, what's going on, everybody? Isaac, redo. Let's do this again. All right, redo. Hey, what's up, everybody? Isaac here with Civil Engineering Academy. Excited that you're here with me again. Thanks for checking this out. Leave us a comment if you haven't already. And hey, share it with a friend because sharing is caring, right? Well, I'm excited today. Today is a great episode. I bring on Dirk Bondy, who is my brother's absolute hero. He is all things post-tension concrete. But Dirk Bondy is a professor, and he actually teaches at Cal Poly State and UCLA, and has his own business called Seneca, and is just awesome. Also a pilot. So mix all that together. I don't know how he does it all, but he does. And we have a really enjoyable conversation about engineers that teach. Maybe you want to go into that arena. We talk about starting a business. Maybe you want to go in that arena. Or maybe you want to do both like Dirk, and maybe how to balance all of that in your own life. So we have a really enjoyable conversation. Dirk is very down to earth, and we just enjoy his teaching style. We'll also link to his YouTube channel. He has some great videos out there talking about post-tension concrete, and it's good stuff. So I think you're really going to enjoy this again, and it's going to be coming up right after this. See you in a minute. All right, I have Dirk Bondy with me today. Dirk, welcome to the Civil Engineering Academy podcast. How are things going?
Great. Great to be here. This is my first podcast ever, and so I'm very excited.
Awesome. I'm also joined by my brother, Mark, who thinks you're the world's greatest structural engineer. And so I wanted to bring him on to help with some questions. So I guess as we...
I love Dirk.
I love you guys. I wonder how long we were going to get into this before we professed our love.
Yeah.
That's great. Well, I guess let's start right at a little bit at the beginning, and that's basically how, your history of structural engineering. Why did you go that route in your life? How did you end up being a structural engineer?
That's a great question, and here's the truth of the answer is. My parents split up when I was about 8 years old and divorced a couple years later. I like the view where you guys are there, but is that possible, or we have to look at me?
We can do this any way you want.
Okay. I feel like I'm talking to you guys, and do whatever is the best. Anyway, back to my story. So my mother remarried and then got divorced, but we moved up to Northern California. So my father, who I don't know if you know, he's a pretty famous structural engineer. He was a big part of Atlas pre-stressing and originally started at T.Y. Lin. He's a big name in Southern California engineering. But I had a distant relationship with him after my parents split up. And I'll be honest, things didn't go so well for me in high school. I was making bad decisions, not getting good grades, and absolutely nothing to brag about. And my mother had pretty much had it with me by my junior year and said, "You're going to go live with your father and get your head straight." And that's exactly what happened. I lived with him for the summer. I saw the lifestyle he led. I saw him as a happy person, and he allowed me to go to work with him. He had kind of a communal office. It was just him and his business partner and a draftsman, but they allowed friends of theirs who'd come from Atlas pre-stressing, which had exploded, and they came in and worked in some office spaces. So I got to see a lot of structural engineers, talk with them. They were funny people. I think engineers are some of the most clever, humorous people I've ever met. Flies in the face of what, as I said, as we're depicted in television and in the movies, we're usually kind of nerdy people. But the funniest people I know are engineers. Anyway, I just like the lifestyle. He took me to his job sites, and I was fascinated with it. And I saw what they did. And I saw people being very happy. And I had been working at a car wash up in Modesto. That wasn't a real happy place to be. I said, to answer your question, I said, I want to do this. I don't know what it is, but I like the environment. I like happy people. My dad came home happy, and I said that's for me. So what does it take? And he said, well, go back, get good grades. I got straight A's from that point forward. Went to Cal Poly San Luis Obispo and was very lucky to get in. I could never have gotten in today with the grades that I had, but luckily back in 1983, you pretty much just applied, and as long as you were the minimum standards, they'd let you in. Um, did well there and went on to. I got accepted at both Berkeley and Stanford for graduate school, and ended up going to Berkeley which was a really great program with really intense professors at that time. So
That's great. That's a great story. So if we fast forward to today, you're teaching now at Cal Poly and UCLA, and you have a business, Seneca Structural Engineering. So how do you manage all of that, and maybe give us a little flavor of what Seneca specializes in?
well, I worked at Engelkert's office for 7 years, and they're a general structural engineering firm. They did the Getty on the Hill down in Los Angeles, and really some major structures. I did a lot of steel, probably did more steel than anything else, and wood and concrete and post tension concrete. Decided at some point I was going out on my own. You know, you kind of hit the point that you're not making enough money, and you actually think you're better than the people who are making more money in the firm, and you have a decision to make. And I decided to roll the dice on myself and went out and tried to be a general structural engineer. And I did. I was working for property companies and I was taking, like you do, whatever work you can get. I was adding mezzanines into warehouse buildings and putting eyebrows on converted warehouses to offices, whatever anybody wanted me to do. But with my last name being Bondy, it was somewhat inevitable. It's apparently in my DNA that I was going to gravitate towards post tensioning as a specialty. You know, and I had my father who was still practicing when I started my own firm, and his relationships, and it just evolved to where it made more sense and a lot more money to just do post tension concrete. I learned quickly that there are very few people who know how to do it, and very few people who know how to do it right. So if I could
Very
just
specialized.
get into that, um, I'd have a nice firm. And I stole a guy that I was working with from Engelkert's office, and Brian Allred, and he does a lot of webinars with SK Ghosh, and he likes teaching also. We both enjoy teaching. So it's just been he and I since 1998. And like I said, we started off general, but it didn't take too long to become just post tension specialists.
So you started your own company. What happened to your father's company?
Um,
Was there an opportunity for you to just jump into that one, or you wanted to do
well,
your own?
so I think I'll just go on my own. I think I can do this, and it was probably the best thing because I've never worked for my dad. He's always been someone I relied upon and could go to, and did use contacts. But it was when I went out on my own. I went out on my own, and
Wow.
like I said, I was working for mostly for property companies, doing PML analyses and whatever it took to pay the bills.
So can I ask you, what are some things, I guess, starting a business has taught you that maybe you haven't never learned in school?
Oh.
I'm
Well,
sure
see,
there's
that's
a
one of the
bunch
reasons
of
I
them.
like to teach is because I talk about those things that nobody in the university levels usually willing to talk about. And there's so many things. There's so many things about relationships, and I have to become a good architect. I have to actually become a good electrician and plumber. I have to know what other people are doing on the project, not quite as well as they do, but I have to know how we are going to interface and help them. And that's a tremendous benefit to anybody who you just good at engineering. You're going to be limited. You have to start getting good at being an architect and being a parking consultant. I've actually gotten to the point where people have tried to hire me to be the parking consultant, and I have to tell them I'm not. I'm not an architect. I'm not qualified to do that, even though I probably can do a lot of it.
Yeah, Dirk, I see a lot of that. I've been in post-tension concrete for over 20 years. I've probably built, I don't know, over 100 post-tension projects in my career. And I get into some of the same situations where I'll get design teams and stuff that'll come in and want me to be the consultant. And
That's
I
the
got to
danger of
step
knowing
back.
how to do a lot of things.
Yeah, yeah.
Ask you to do it.
How I know how big a parking stall is. I can lay this thing out, but we really need to get
Right.
an architect that can look at things at a 30,000-foot level and make sure we're all code compliant on everything. So yeah, that's an important aspect.
Yeah, I do tell my students, and I love teaching because I love those young, sharp minds, and they're so eager to learn, and they really want to hear what it's like. And I can still remember my first day working at Engelkirk's office. I mean, I remember how nervous I was, how much I realized I didn't know. That's terrifying. And that's coming out of Berkeley with a graduate degree, thinking I'm pretty hot stuff. First day at the desk, it's like I don't know anything.
That's exactly right.
And so I can relate to these students. When I get them, they're seniors in the spring quarter or they're graduate students. I usually at both UCLA and Cal Poly have about a 50-50 mix of undergraduates and graduate students. But they're all right on the brink of going out to get a job. And they're terrified. I remember what it's like, and I love talking to them about it.
Well, I guess as we talk about post-tension structural concrete, for those that don't know, because we have a wide range in our audience, but those that don't know, where is post-tension structural concrete mainly found? Where is it used?
To be honest with you, it's everywhere now. And that's it's exploding. It's every building type you can think of can be done in post-tension concrete. And the more structural steel gets expensive and more steel gets expensive, the more popular post-tension concrete has become. I mean, it's just overwhelming. People ask me, why do you teach and tell everybody how you do what you do? And I say, because there's so much work out there that we won't be stepping on each other's toes. It's in my benefit for you to do it right. But parking structures are big. Hotels, almost every hotel you'll stay in that's over 4 stories will be post-tension concrete. Office buildings, condominiums, apartments, assisted living facilities. We've done medical office buildings. To be honest with you, the invention of the stud rail, the stud rail for punching shear, that opened up a whole world for us. When we could get away from having that big blob of concrete, that column cap, which architects absolutely hated. When we got away from that, that opened up really every single building type to us. Anything that was built in steel on a 30 by 30 grid can be built in post-tension concrete in that same grid. And I'm really sounding like a salesman because I am. Our total structural system depth will be about 8 inches, the whole thing. Whereas with steel, just their depth, their metal filled decks is 6 1/4. Then they've got to get to the beam itself, and we're talking 2 feet of floor of difference. And that
Dirk, I've been involved with projects like that where we've made relative comparisons, where we've taken structural steel buildings that are designed with structural steel, created an equivalent post-tensioned building, same number of floors, same number, same space, same footprint. And, we save, 50, 60 feet on the top of the building, and they save a bunch of building skin costs because we get all the same mechanical equipment, everything is all there, all the space that the end user needs, the owner, but we do it a lot more, economically that way, and not only saving in building skin costs, but there's a lot of other aspects of structural concrete, the thermal mass, that's involved with it. That a lot of people.
Air conditioning the building is cheaper. It's just a smaller volume. Like you said, the skin.
All that concrete, that thermal mass, like a big battery, right? And so you don't get the big swings in temperature as the sun comes up and cooks the building and then goes down at And so that causes less demand on the mechanical system. So I'm sure you've seen some of those things get realized in your career.
It's hard for us to weigh less than a steel building, but for any other type of concrete building, post-tension slabs can take out a couple inches of slab mass. That lightens the seismic loads, lightens the column loads, lightens the foundation loads, and the savings just reverberate through the entire building. And people really, we have a really flat floor and it doesn't bounce. And, I just go on and on and on, but
yeah,
that sounds really nice.
Terrified of post-tension concrete. Did you know that I teach in both the University of California and the California State, Cal Poly's Cal State and UCLA's UC system. Both of those school systems, for decades, it was illegal to build post-tension concrete for any of their buildings on their campuses. They were absolutely terrified of it. I now sit on the seismic review board for the Cal State University, and they, not too long ago, just decided to allow post-tension concrete, except for parking structures. They would allow that, but any of the dormitories that were being built, they couldn't be post-tension concrete. It was just the fear that was out in the industry about putting these very large forces purposely. Who would do that? Into a building. We're against that. We want small people. We cross our fingers that we'll never get any of the loads that we designed for and try to sleep at night. And you crazy people go out and actually put these enormous loads into the building. Nuts.
Yeah, you're nuts.
Well, why don't you, while we're talking about this, what are some of the common issues that you see with post-tension concrete? It definitely sounds like the benefits are innumerable, but what are some of the issues that you see with post-tension?
Well, we talk about that all the time, and that's the fun stuff. Brian, my business partner, loves to do those webinars for SK Goshen, throw out the pictures of exploding concrete, and that, unfortunately, those things do happen. You need a good structural engineer to design it correctly, and you need a very qualified contractor to build it correctly. And if anybody gets cavalier on their part, you can't trick post-tension concrete. It will find your mistake, it will find the flaw, and it will pronounce it to the whole world. So
no hiding.
There's no hiding. So you really do need to know what you're doing. And that's one of the things I teach my students is, in every other material, you can over-design. You can put, 18 by 35 can be a 21 by 44. No harm, no foul. You can always make the wood size 2 inches deeper, use the deeper glue lam. In post-tension concrete, more is usually worse than less. If you're going to err, you almost want to err on the less side of post-tension, not the more side. Because once you start putting in more than you need, you have the restraint to shortening. The building starts squeezing and pulling itself in too much. And you can have the overbalancing effect of literally shooting the concrete up in the air.
Hey, Dirk, this goes into your cowbell story, does it? More cowbell.
Exactly. That's the story. That's how I communicate with the younger generation through Saturday Night Live skits. But that's exactly it. I teach my students it's not more cowbell in every other material, every other aspect of structural engineering, not in post-tensioning. We're the less cowbell group.
Yeah, Dirk tells a story about him being up at night late and watching old Saturday Night Live skits, and I think that was one from who was in that skit? What that you talk about?
Will this one in there. I'm blanking on who the other one was. The guy actually says more cowbell.
Walken.
Christopher Walken.
That's absolutely right. I should know that a little bit better. I get emails from around the world all the time about cowbells and people sending me pictures of cowbells.
Oh my gosh.
Kid, I think Chris
Walken and Will Ferrell and a few others.
And no matter how bad the music's getting, it's always more cowbell. We need it louder.
Exactly. I need more cowbell. So
Yeah.
I need to go watch that one, apparently.
That one, the students have always related to.
Yeah,
great.
I like that one.
I put something on the final usually about cowbells too, just make sure they're watching the videos.
Well,
great.
Speaking of students, I have a question for you about them. So if someone was just starting their journey into the structural engineering world, I guess what advice would you have for them?
I give this advice a lot. I mean, be patient. The students are going to go in and they're going to look at, they're all interested in how much money they're going to make. And they're usually disappointed when they see what the structural engineer makes right out of school compared to their construction management friends, their computer software friends, their almost any other friends. And I tell them, you've got to understand, we're more like doctors than anything else. You'll graduate with a degree, and my son's in medical school, so I make this comparison analogy, but that's really just a license to start learning. And like I said, I was talking with you guys, I think before we hit record, that my first day on the job, after being a graduate from Berkeley, thinking I was hot stuff, I was terrified, and I realized how much I didn't know. And the states that license us know that. They know you're not ready. So that's why it takes 2 years to even be allowed to sit for the professional engineer's exam. And then it takes 3 years after passing that exam to even be able to sit to be a licensed structural engineer. And they're not just being mean to us. It is 5 years of true learning that it takes before you are really qualified. And that's really just as you're getting to be really qualified to go out and make decisions on your own and really represent yourself as a person who can be trusted by the state, the architects, the owners, that you can really do this. And at that point, I've always said they should do a salary check on people 5 years into their industries, not out of school. And if you've worked hard and you've learned a lot, you're much more marketable after you get those 2 licenses. So that's my advice to somebody going into it.
That's a great advice.
World, it's you get to learn about all kinds of different materials, and I always tell my students to try to go to one of the larger firms, learn how to do everything, because that's how you're going to pass those exams. Your main focus should just be passing the exams for your. They think 5 years is forever. It took them 4 years to get through college, and it seemed like forever. And 5 years is just so long. I'm 57 years old. That's nothing. It's a tiny amount of time. There's so much time after that.
And it goes by so much faster when you're out of school too. Just so you know, like as soon as you start working, years fly by. And
I tell them it's easier too. It's never going to be harder than it was in school. You're going to learn some tough things, but most of your days are more enjoyable. You're learning, but it's nothing like being in graduate school or something like that. And 7 days a week, always having exams and projects hanging over your head. You actually get to go home at 5:30 or so and go enjoy yourself. And it'll all be waiting for you on your desk when you come back at 8 the next day.
Right.
Or a couple phone calls in the night. Who knows?
Yeah. Now that we have email constantly on our phones, it's a little harder to walk away.
Well, what's your? I wanted to ask your opinion or get your thoughts on the difference between grouted and ungrouted post-tension concrete systems and where they're used.
Grouted is used in communist countries. Probably gonna have to edit that out. I get lots of emails from people all over the world. Some of them are communist. I love everybody. We talked about how everybody was scared of post-tension concrete. And it was that fear, in my humble opinion, that leads to, still to this day, needing to grout post-tensioning. It's the worst thing that can happen to it, to be honest with you. Unbonded post-tensioning is almost impossible to fail. And we learned that in earthquakes in California, in Northridge. the tendons can bend down to the next level without breaking. They saved lives, and in ways they were never intended to, in ways they were never designed to. But as soon as you grout those tendons, then the whole idea is to make them like rebar, have strain compatibility, have them bonded, so that in the unlikely and strange event that a plumber comes by and cores right through them, it'll be like rebar where they redevelop themselves within so many feet. But by grouting and making it strain compatibility, all that, you now introduce the potential to rupture that steel, just like mild reinforcement can. And it takes away the greatest benefits of post-tensioning, which is being unbonded, being almost unable to fail. I mean, as long as somebody doesn't core right through the tendon, it will be there forever. You know, we're now encapsulated. This code requires, since 2014, has required full encapsulation for all building post-tensioning. So it's completely isolated now from the environment. You pour water over it, salt water, nothing can get to it anymore if it's installed properly. And it's almost indestructible unless somebody cores right through it. But my argument has always been, you can't design assuming somebody's going to do something stupid. You wouldn't want anybody just Swiss cheesing your mild reinforced deck either. I mean, that's just as disastrous. So that's the only reason that I ever hear for grouting post-tension.
Okay. Well, I feel like I've asked a lot of questions. Mark, what do you got on your plate? Maybe you got a few you want to explore. You want to ask?
Dirk's, as I've mentioned, he's very grounded, kind of practical type engineer. He's worried about constructability and those types of things. If I can speak for you,
you do better than I do.
I'm thinking back, going through your courses and some of the things that you've talked about, and one of the things I love is your approach. That you talk about moment distribution and dealing with indeterminate structures, and the old way of doing things are still valid. These days in finite element analysis, and we can create these fancy 3D structural models, and they're fabulous. But if you don't have those core skills of moment distribution and to be able to check those software, those big fancy software programs, then you can't, it's like a black box, right? You're just running input into this black box and it's cranking things out. How do you have a feel for what it's telling you, unless you can use some of these I like to call them old school structural approaches to gauge whether you're getting adequate output from all of your input? How do you gauge yourself?
No, absolutely. The interesting thing with COVID is I'm an outsider in the universities. They, be honest, they don't want me there. I don't really belong. I'm a practicing engineer who steps into their world, and I know, well, I definitely know that I'm not big fans. And one interesting thing about COVID was I never got invited to the faculty meetings until COVID. Then everybody was on these links and they would send it to me too. So I would get in on them, and they hated having me in there because they want, the next greatest thing, the next greatest software. Let's get rid of, and that most schools got rid of pre-stressed concrete as a time. It just wasn't fun enough. It wasn't interesting enough. I don't know what the reason was, but both Cal Poly and UCLA had canceled their pre-stressed concrete class. I started teaching at Cal Poly 2 years after they canceled their pre-stressed concrete class. UCLA in 2011 hired me, and I didn't realize at the time that they were hiring me to teach the very last time they were going to offer pre-stressed concrete. It was kind of poetic to have me. My dad had taught that course in the 90s, and John Wallace asked me to teach it. And like I said, I didn't know it was the last time. In the 7th week, he met me in the hall and said, "Well, thanks for doing this. If we ever teach this class again, we'll call you." And I was kind of devastated. But anyway, to go back to the topic, they have me on these, and I just step in and say, "No, it's about fundamentals. We're, it was hand drawing, and then it was ink drawing, and then it was AutoCAD was the new thing, and there was something before AutoCAD, and now it's Revit." But I said, we're constantly going through, it's three-dimensional finite element. But if you look at the building, it's always the same building at the end.
Exactly.
Don't know. Was that a hand-drawn building? Was that a Revit building? Was that done in AutoCAD? Was that a finite element?
Right.
It's always the same thing. The 8-inch post-tension slab always goes 30 feet.
Right.
By 35 always does it the same thing. Deflects the same way. So I couldn't be more with you. It's always, especially in the universities, about the fundamentals. Just get down to the brass tacks. And then, as long as you understand those, any software change that comes later, any way of presenting the model, drawing it, you'll be able to adapt because you understand the fundamentals.
Yes, and I love that. I love that teaching from you, that you try to convey that to your students. That get that fundamental, that foundation. Make sure that that's solid, because all these other things, they're nice fancy tools, and they'll help you be more efficient with your design potentially. But you got to have those foundations to actually know what you're doing.
Absolutely, and that's what I'm trying to do.
Which leads me to asking you to talk about your pig farmer story, because it goes right into that concept.
Yeah, no, it's just I was in a mood that day.
You didn't know I was going to bring up all this fun stuff.
No, I have to remember back what I was. No, it's just basically the mob mentality. The pigs can run and forage for themselves, and they're strong, and farmers learned how to tame them basically by putting up one fence and giving them some food. And after a while, the pigs on their path would divert off and eat some of that. Farmer then puts up the next. This analogy has been used for politics typically, but I adapted it to structural.
Yeah, I love it.
Basically, taking a wild, strong group that's fully functional on their own and teaching them to be complacent and need what they never needed naturally. And it's taming of the wild pigs. And eventually the pigs like the free food. They don't care that the fourth wall got put up, the fourth fence got put up, and they make a choice to just stay and wallow in their own filth, I think, as I say.
That's right.
Get fat and forget how to hunt, to forage. All their muscle goes to fat, and they're happy and they're okay with it. But
they get slaughtered, right?
They end up getting slaughtered that way. And that's the analogy I've used to the software developers are trying to just get everybody to do the same thing, not think about it, not think about the fundamentals. If you can go to a 3-day seminar on how one of these very sophisticated programs is taught, they only teach you how to use the program. They're not teaching you the fundamentals of what the program does. And there's almost no access to it. And, I've got a lot of opinions, but I don't think they want you to know. I think it benefits most of the software developers for you not to know what it is that their software is doing. They want you to trust them implicitly and just get to the point that you don't really need to know what it's doing.
Plus, I think that commoditizes engineering, Dirk. Don't you think that has an effect of like making engineering kind of a commodity rather than a...
Well, absolutely. I mean, I depress my students when I tell them this, but I say when I started, I worked at Engelkert's office. We had 42 people when I started. There was one room and it had 3 computers in it. It had a Mac and 2 PCs. And you had to make the decision to stand outside the door and wait for whoever was on those computers to get off to decide to go in and model and do whatever you needed to do. But alternate choice was to do it by hand or do it with the steel manual or do it with some charts back at your desk. And you had to weigh that. But you always knew what you were doing. And we also didn't trust the computers. They had bugs in them. They were written by other structural engineers. There was no computer science majors really back then writing these things. It was one engineer writing it for another. My father wrote PT data and then just sold it to his friends. And that's who used it. And they would call up and say, hey, something weird happens when I put a cantilever in, and you're going to need to focus on that. This isn't right. And that, picking up the phone and talking about bugs. And that's how software got better, got refined. Things are all different now. I mean, things are. So
how has things do you still do peer reviews where you have to review other engineers' work, and has peer review
makes me suicidal.
Get worse because of the ease of using the packaged software that's out there?
I just ask in our peer reviews, and so does Brian. We do a lot. We work for the city of Newport Beach. We work for the city of San Francisco, and we do peer reviews on theirs and others. And I just ask simple questions. I'll see a column with the same loading, the same tributary area, the same spans. One column has 5 number 6s over it, and the other one has 14 number 6s over it. And I just ask the question, why? What's different? The loading doesn't look different. The spans don't look different. The tributary is not any different.
Right.
And all I get back is, we have verified the input with the computer program. It's all correct. No idea where any of that reinforcement comes from. Is it minimum strength? Is it over?
Right.
And it's just so frustrating to just try to ask a simple question.
Right.
Why is this not like that?
Right. Well, and you got like, I'm sure you've served as an expert witness where you have to come up against somebody like that's produced
another
fancy
thing that makes me suicidal. But yes, I have done that too.
Yeah.
It's kind of funny. I've got funny stories, and I do tell my students that someone comes in and they're cocking chests out. They've been running the most sophisticated software, finite element. And then I come in with PT data, it's just doing a strip method, and I can do everything in PT data by hand and do. And then somebody brings in the simplified ADAPT, also doing the same thing. My dad and Bijan were competitors. They did ADAPT in Northern California, and PT data was Southern California.
Yeah.
But it's doing the same thing. And we both, ADAPT and PT data, came up with the same thing, and the sophisticated person came up with something totally different. And we start explaining why exactly we got our answers. And we ask simple questions. Like I said, why is that 14 number 5s and not the same 6 number 5? And you see the sweat just start. These are radiations too.
Right.
And, we smell a little blood in the water, and we start asking other questions. This doesn't look right here. Where would you find that? And they've got the stats about, but they're like, well, it would take me a while to figure out that. And even the mediator will say, well, we'll take a break while you look this up. We'll go get them back. And they can't find anything. They don't know how the computer runs. They don't look for anything. And the mediators have said, and this happened twice, just you don't seem to understand your own program. So I'm going to go with these other people that seem to implicitly understand theirs.
Yeah. Yeah, that's why I love your approach, Dirk, because you got that practical approach. And I don't know, just going back to the old school ways, and I know PT data and some of these other things, still serve as tools for you, but the old ways they're not outdated. They teach you those fundamentals that you've got to know, So I think that's a really cool thing.
Yeah.
Yeah, that's a really cool thing that you try to teach, and I'm sure that drives a lot of your desire to help students and your desire to teach, is to convey some of these important concepts like that.
Well, I mean, I start getting in my own head that I'm the only one doing it. I'm sure I'm not, but trying to find somebody else that's just.
Well, I try to do that kind of stuff in my practice. So you've converted
engineers who go in, and I really would always hope that practice engineers would make time to try to go into a university and teach, especially when you can start doing it through the internet now too. I think that is the next great thing for teaching, for universities. It shouldn't be limited to who can get inside the brick and mortar walls to teach the classes anymore. And
that brings me to another question. Just with all that you are doing, if engineers want to be teachers, do you have tips around people that want to get into that arena? Or it sounds like what you're suggesting is that everyone should maybe test that water and help the next generation. So
I think buying an airplane and becoming a pilot helps.
That's what you've done.
I did. I saw that question coming up, so I know it's coming. But I was up at a fundraiser at Cal Poly in 2014, and they had canceled their pre-stressed concrete class. And we talked about Bajan Alami. Florian Barth was his partner in BFL and ADAPT. Florian's son, Florian, also named, was in the graduate program at Cal Poly. And at this fundraiser, Florian Sr. said to Al Estes, the department head at Cal Poly's Archie department, said, "I'm really frustrated. My son's going to graduate from Cal Poly with a master's degree and never once take pre-stressed concrete." And Al's face kind of went white, and I don't know, it was kind of an out-of-body experience. I heard somebody say, "I'll teach him how to do it." And that was me.
Yeah.
And I said, I'll fly up. I'll fly up and teach Florian how to do pre-stressed concrete. And like I said, it was an out-of-body experience. I don't know what I was talking about. I hadn't put it all together yet, but I was in this, conversation, and I ended up, and Al said, okay, and it got him out of an uncomfortable situation with Florian. Florian Barth, by the way, is the biggest donor that their Cal Poly's Archie department has ever had. So they want to keep him happy. And so they didn't pay me, which is fine. I flew up every Friday. It turned out I had 9 students, because students are smart. When they realize that one kid's dad, who's a famous structural engineer, thinks he should take a class, they should probably take the same class. So I ended up having 9 graduate students, which was almost their entire department, I think. And we didn't have a classroom. So we just kind of met out on the lawn till the weather started changing. Then we went to the grad lab and kind of took that over. But I taught these students pre-stressed concrete, the same class I'd been teaching at UCLA. But they used the videos that I've got a whole video story if you want to hear it later. But they used the videos that I posted on YouTube, and they did really well. And this was back when Al said nobody can learn by videos on YouTube. There's no way that's going to be successful. COVID came along and everybody proved that wrong. But that was back 2014, before COVID. And these students really got it. And they went back and said, this class needs to be taught. And I've been teaching it every year since then.
That's awesome.
But I do fly up. I do meet them in person. I do think that's important. You can do some of the lectures online, but you've got to have some face-to-face with them.
Yeah.
It can be Zoom. It can be like this, but nothing's better than standing in front of them. It's also nothing's more terrifying too. You stand in front of a group of really sharp students, and between Cal Poly and UCLA, they get the best young minds in engineering that there is. And for an old guy to stand up there and try to go toe to toe, and they smell blood in the water too when it's out there.
Oh yeah. Anytime you stand in front of a group of your peers, it's intimidating, isn't it? And
well, young, sharp minds. And these guys, like I said, these guys and girls, in fact, my Cal Poly class was 23 people and 16 of them were female, which is absolutely fantastic. They're so sharp, and they've gone the whole 4 years. So they're all tuned up, their brain, they've just done all 5 quarters of calculus and thermodynamics. And I mean, they are really firing on all cylinders. And I've got 2 cylinders left, But to have to stand up in front of them and go toe to toe and answer their questions, what if this, and why don't you do that? And you sure you're right about this? And you're fielding that, and it's great. That's my main, it's great to teach young people and be a practicing engineer, and they appreciate that. But it's the benefits to you for doing that, for keeping yourself sharp. There's nothing you can do other than maybe computer programming to keep your brain and your mind nimble and sharp, like teaching a class. You have to anticipate everything.
Yeah. Well, that's awesome. Great tips. Boy, I think we could go on and on. I don't know, but
we might have to book him for another session.
I'll take it. Let's sign me up.
I'll have to do another one.
This is fun.
This has been really enjoyable to just kind of get your ideas about just a wide variety of topics. So I appreciate you coming on and doing this with us. What's a good way for our audience to connect with you, Dirk?
I enjoy getting emails from all over the world. People are watching I just got told by YouTube I've exceeded 10,000 followers on YouTube for my videos, which that made me feel great because I've never advertised it. It has to be word of mouth. Nobody, they have to stumble across it or be told about it. But Dirk at SenecaStructural.com. That is the best way.
Perfect.
Seneca spelled SENECA. Structural. Hopefully, everybody watching this can spell that.
Engineers don't know how to spell sometimes.
So I'm happy to answer emails. I get them all the time. To be honest with you, I get them from so many places all over the world that my business partner, Brian's got a friend who works in the FBI and says, he's probably being monitored right now. Why are you getting emails from Pakistan, Saudi Arabia, and Indonesia?
You might get some more now. We'll make sure to link that in our show notes and your YouTube channel too, so people can learn what you do and enjoy some of the material you have. So, Dirk, we appreciate you jumping on. Thanks for joining us.
Thank you so much.
Yes, thank you. Thank you, Dirk. Yep.
It's been fun.
All right. We'll talk to you later.
Okay. See you.